Hi. So we are here to listen about Kubernetes on bare metal. Scary, isn't it? Something like COBOL microservices, isn't it? In this talk, I will try to convince you that it's not as bad idea as it might initially seem. But before I do, a couple of words about me. I am a DevOps solution architect. I work with Java and Scala. When I don't work, I usually like to get some science fiction, good music, and I'm also an active DIYer. So, to raise your blood pressure on this Monday morning, I'm going to tell you that there's going to be money in this talk. So I know it's a cheap trick, but what would you expect from an online advertisement company worker? So here you go. Now that I hopefully have your interest, the main question is why? Why on earth would we run a Kubernetes on bare metal? Are we insane, or are we just like, do we like pain? Well, in Poland we have a saying, if you don't know what it's all about, it's about money. And again, it's about money at this time. So you probably would like to know how much money. But before I tell you, let's dive a little deeper in our business model. For years, we've been doing our business with bare metal, but what kind of bare metal? You can go with your own servers, you buy it, you collocate them, or you keep them in your own data center. You can go with dedicated servers, or you can, well, try something else. I don't know what, but you could. Or you just go to the cloud. So the collocation was a little bit economically out of the picture because you have an initial cost quite high. So we've been running for years on dedicated servers in a commercial data center. When we talk about dedicated servers, let's have in mind a picture of a garden variety machine like our typical workhorse. 4 cores, 8 threads, 30 gigs RAM or more, and a decent storage, usually SSD drives. You can get this kind of hardware for about 39 euros from Hetzner, which translates roughly to 170 zlotys. From OVH, it costs a little bit more. If you want to get similar firepower from AWS or Google, you have to cough up over 900 zlotys. As you can see, it's quite of a difference. Even if you go with spot instances or preemptible, you still can't match the cost of your bare metal dedicated server. And if you multiply this difference, it's about 700 zlotys by 100, 200, or 300 servers, you get a considerable savings. And let me put it also another way. For each machine in each virtual machine in Google, you can get 5 or 6 bare metal machines at Hetzner. I don't know, but you can over-provision like crazy and still get ahead. But if you go with managed Kubernetes, it's not the end of your costs. AWS will charge you about $144 per month just for your cluster management. When we started this adventure, the Google also charged for the cluster management. They don't anymore. However, the virtual machines are a bit more expensive at Google, so the cost is almost the same. You will also be charged for storage and network transfer, all of which comes in bundle when you go with dedicated servers. And here's a news, and no, Hetzner didn't pay me for that, for putting that up. A couple of weeks ago, they introduced a new line of servers. They have not 4, but 6 cores and 64 gigs of RAM and 2 decent SSD drives, so it really looks like a bargain. Of course, there are upsides and downsides to this kind of solution. Let's start with the upsides. First of all, you get physical storage. This thing is often marginalized because, well, if you go to the cloud, you get the EBS or something, and off you go. But we have had considerable problems with this kind of solutions performance. Of course, somebody could say you always can get a virtual machine with an SSD drive at AWS, but you cannot treat it as a durable storage, as it will get lost when you give the machine back. So you also get the control over your hardware. You have no more noisy neighbors problem in terms of computing power and RAM and so on. The only way you can get a noisy neighbor problem is still the network, but taking this kind of thing out of the picture is virtually impossible without moving to your own data center. And of course, you save a lot of money. When it comes to the downsides, you have no network storage out of the box. You will have to come up with a solution of your own, something like Ceph or GlassFS or something other if you'd like. You will need to manage and control all of your hardware and operation systems. You have less elasticity. I mean, you can get a new machine within hours or days, not within minutes or seconds. And obviously, you have no auto-scaling. I cannot imagine a solution that connects to, let's say, Hetzner or OVH API, orders you a new machine, performs all the pre-flight tests, and connects it to your Kubernetes cluster. I think that is not going to happen very fast. This is a time for a small disclaimer. Your use case might not be the same. Your use case might be slightly different, so that all of what I've shown you before and all of which I'm going to show you next is not applicable to your workload and characteristics. First of all, you need to think about scale. If you are going to create a cluster that has 5 nodes or 10 nodes, you are probably better off with managed Kubernetes with AWS, Google, Azure, or anything else. It also depends on your workload characteristics. If your workload is spiky, and I mean spiky in terms of 1 order of magnitude, 2 orders of magnitude, or nothing happens during the month, and then at the end of the month you suddenly get a huge spike, you are probably better off with cloud too. And there is also security concerns. If you let's say, work for a bank or a fintech, and moving to a public data center is out of the picture. Some of my advices might not be applicable, but still some of them might, so please don't leave just yet. So let's move on. As everybody, we needed a good plan. Those guys are the best when it comes to the plans. So we didn't want it to be worse. Our plan, let's say what we started with. We started with experience with operation on the dedicated servers at public data centers, vendors like Hetzner, OVH, and so on. Usually the more economical ones, if you know what I mean. So we knew what to expect, and we had in place procedures for mundane tasks such as bringing a new machine into the line, returning a machine back to the vendor, and so on, which are, by the way, not so trivial as you might think. The pre-flight tests on the beginning and cleaning up the machine can be a real pain. When it came to cluster specifications, we decided to start with 5 to 7 nodes in total. 3 master nodes, those were to be working as both as masters and slaves, so they would be tinted. We wanted to have full monitoring and before going to production, and be ready to production in 6 months. Pilot application. We didn't want to go with our main components as they were mission critical, so we chose an application that we were about to deliver. And the specs were as follows. All of the components were to be stateless, loosely coupled. All of them should talk to each other via HTTP, HTTPS. All of the databases excuse me, were to be outside the cluster, and we didn't want to do any auto-scaling at the beginning. It was also the time to think about security. And when it comes to the security, first of all, cluster access, SSH cluster access, was to be limited to essential personnel only. All of the others, I mean the dev team and so on, were to be using local kubectls and connect to the API server. API server itself needed to be accessed with an individual token. Each of the employees and systems were to be issued individual token. Those tokens were to be inventorized and rotated accordingly. All security was to be done using role-based access control, RBAC. And when it comes to application security, all communication with outside world via HTTPS, all communication with outside world, I mean every service is exposed to the outside world were to be exposed via ingress. And of course they were to be inventorized. We didn't want anything deployed unless everybody knew what it was and what it was for. Now the teams. When it comes to the teams, I would like to emphasize that we wanted teams, not as single individuals. You don't want a one-man army creating and maintaining your Kubernetes cluster. Well, a single Rambo can get sick, can quit and leave you with a cluster that suddenly fails and you are dead in the water. And from the other perspective, you don't want to be a single Rambo yourself. Imagine you have some holidays. You go to some tropical island, you lie on the beach, and suddenly there's a phone call. Get up and come to fix our cluster. It's down again. You see the problem. So you want a team, and I chose this picture to illustrate the team issue not by accident, not randomly. Those guys are really good at transferring knowledge between each other, and your team should be equal in those terms. So you don't want a leader that just knows everything and everybody is afraid to push any button without asking him. It's just back to the single Rambo scenario. So we wanted a team, actually 2 teams. One of them would create a pilot app, create and maintain continuous integration and delivery pipelines for it, and configure ingress. On the other hand, the second team, let's call them ops team, was to create a cluster, administrate it, and create and check all of the administrative procedures. The procedures, let's divide them in 3 categories: administrative, maintenance, and disaster recovery. By administrative, I mean creating a cluster, adding a new node, and so on. Maintenance is caring, it's about caring about the security, managing users, rotating tokens, removing a node for maintenance, reconnecting it again, and so on. And of course, disaster recovery. We wanted to be ready for any kind of disaster, from single node failure to complete cluster breakdown. So we, for example, have in place a procedure that backups all of constantly backups all of the cluster state and allows us to recreate it in other production environment. Training. Training is not the easy part. You need to have some kind of training environment. We started off with a minikube, which we grew out of pretty fast, as it's just a virtual machine with a single node. Then we have moved to physical machines, and here is our first error and your first advice. Running physical machines in your own server room might be a little different than running a Kubernetes in a public data center. And it usually shows up when it comes to the network configuration. In your own server room, you just create a VLAN and the network is secured. In your public data center, you might not have such a luxury. So if you are going to deploy to dedicated servers, you probably should consider a sandbox in your target environment. Also, training should have a different approach when it comes to developers and ops teams. When you train devs, you probably should focus on entities that they are going to work with, and to address some problems that may occur from, let's say, misconfiguring, for example, limits or requests and so on. I'll have a funny example at the end for that one. When it comes to training ops team, it's another story. They should know intimately the internals of the cluster, and they should know how things really work. Now, the piece you are probably waiting for, the problems. No, you call them challenges now. So challenge number 1. Networking and firewall. I started with that one a bit earlier. So you probably going, if you're going to a public data center, you have to secure yourself somehow. Some of the vendors will allow you to create your own VLANs. With other, you will probably need to go with some kinds of VPNs or overlay networks or something like that. Remember that Kubernetes relies heavily on filter and net tables. So you won't be able to create your firewalls as you usually do. At least it's not a trivial task. The only table that Kubernetes doesn't touch, or I never noticed it touching this table, is Mangle. However, as every sysadmin or net admin will tell you, you should not use this table for creating a firewall. So we've come up with a 4th solution. We introduced middleware. We used Proxmox. It's a virtualization service that allows you to create and manage virtual machines. It has a nice graphic user interface and allowed us to create something like that. We sliced every machine into smaller VMs. The smallest ones were to be used as master nodes, as they don't need too much computing power. The larger ones were to be used as workers, and that addressed another problem of possibility of worker tasks starving off the control plane. And Proxmox gives you another advantage. You get a Ceph cluster out of the box almost for free. The other challenge was logging. Kubernetes comes with the default mechanism which we have been using for some time, and then we decided that we wanted to do something more durable. So we created an ELK cluster, I mean Elasticsearch, Logstash, and Kibana, and tried to put our logs there. However, it turns out that with our workloads and our log policies, if we scale it up for all of these systems that we are currently using, this solution is not economically viable anymore. So we are thinking about third way. Currently, it's work in progress. We are entertaining a thought of using our HDFS cluster for storing the logs, but I cannot say anything more at the moment. There's also a challenge of staging production separation. Of course, you could run, excuse me, all of your workloads on the same nodes and say, YOLO, whatever happens. However, it's quite dangerous, as if your applications go wild on staging, consume resources, they might cause you service degradation or entire system failure. So we went with a solution when we separated nodes. We labeled each node production or staging. We deployed our systems accordingly, and it worked for some time quite good. However, one day, one guy decided he wanted to run a load test on the staging. So he did, but he did it via a common ingress, which led to a service degradation. Fortunately, we caught it quite fast, and it didn't cost us that much money, but still it happened. So what can you do to prevent this kind of situations? First of all, you could create separate clusters and separate your environments entirely. However, with the solution we have chosen for continuous integration, it was not entirely on the table, as the GitLab continuous integration and delivery engine in our version allows us to connect only to one cluster. So it leaves the other option, which is to separate ingress for staging and production accordingly. Actually, you have two ingresses then. Incidents. And this is the part when things start to blow up. First of all, hardware faults. And I decided to order them from the most common to the most rare. Most common problems are quite trivial. If you run on dedicated servers, you will run into problems with the cooling pretty fast. You rarely get machines that are brand new. Usually the machines you get have quite a mileage on them. So fans just die out. It's maybe not the most well, let's call it. It's not. It's a trivial problem, yeah. But it still is annoying and will require you to pull a node out of the cluster, get it for the maintenance, and then to reconnect it. So it will cost you some time. The other most common problem is power outage. And those usually happen in form of a machine just dropping out and coming back again to life. With our Kubernetes cluster, those were quite harmless and usually didn't require any manual assistance. The cluster just came back to its original state. Disk failures, and those are pretty harmless if you prepare for them too. If you are using RAID in configuration 1 or 10, you probably won't even notice it. And as most of the current servers have hot swap disks, you just place a ticket and the disk gets changed and nothing wrong happens. And the last kind of hardware problem we encountered was faulty RAM, and this also required manual assistance, taking the node to the maintenance, then reconnecting it back again. We have had also network issues, from common package loss to total network outage and split brain situations where machines in one rack didn't see machines in the other. But those were handled by Kubernetes also pretty well, and it always came back to life with no manual intervention needed whatsoever. However, we have had a curious incident with the network when Kubernetes configured or reconfigured the routing table so that some of the traffic from internal overlay networks leaked out to the public network of the data center. which caused all of the alarms at the Hetzner to go off, and it resulted in they cutting us off for some time until we pled guilty and promised that will not ever happen again. So just as a precaution, as I said, it happened only once, and we haven't recorded any such issues again. But just as a precaution, we configure our firewalls not to let any of the internal traffic to the public network, just to be sure. The Ceph issues. We have been using Ceph as we got it almost for free with the Proxmox. And here's another story that might hit you as it hit us. When you write on disks that are not so fast and a network that is not so performant, and your cluster is not that big, I mean a couple of nodes, and you lose a node, it will, of course, begin to heal itself, and the cluster will begin to heal itself. And if the network is not so fast and the disks are not so fast, it will probably saturate itself, resulting in repair hiccup, so we called it. If a node drops out, you might experience even temporary service degradation or entire cluster stops. It is because the etcd underneath cannot write the new state to the disks that are underneath the cluster. And as it cannot write a new state, it cannot go to another state and then another. And the whole thing just freezes until the disks are responsive again. So if you are going to use Ceph, it would be better to check this kind of scenario before you go to production. Of course, there are no free lunches, and every technology that you bring to your stack can also have its downsides. Proxmox is no different. First problem we have had with it, it was an automatic update. Some of you might ask, what can go wrong with automatic update? It will just, well, install the new version and you will have a secured cluster and so on. I tell you what can go wrong. The nodes reboot and fail to boot again. So if you don't turn it off in time, you might wake up someday with half of the cluster, if you're lucky. If you are not lucky, you will wake up with no cluster at all. The other kind of issue, VM restarts. If you write pretty close to the limit with your virtual machines on Proxmox, you might be able to boot them sequentially, but if you try to boot them all at once, they will they might not boot at all. So it's good to know that kind of things. And excuse me, I'm a little bit under the weather today. And of course, Proxmox has also some issues with service exposition. It's not trivial and will require you to get your hands dirty with IP tables. And here's the bonus I've been talking about earlier. This one has nothing to do with bare metal or dedicated servers whatsoever, but it's fun, so I decided to share with you. Let's Let's imagine we have a cluster. We have a cluster that comprises of several nodes, everything works fine, and someday a guy from the developers team comes over and says, well, we have had some problems with those limits and requests. The applications weren't performing as we expected, so we lifted them. So you are like, you lifted them, you mean you make them bigger? No, 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 we got rid of them entirely. No, you shouldn't do that. What do you know? Hold my beer. And then nothing happens for a time. They just put another pods to the cluster. Everything works okay-ish. And then one day, a node fails. You know what happens? Well, Kubernetes does its magic and tries to distribute the pods from the fallen node to the other ones, but it runs off the resources. So it starts to kill off the other pods at the random, because when you got rid of all of the limits, everything is quality of service, best effort, you know. So it kills off those pods at random and tries to recreate them on other nodes, and other nodes became clogged too, and you end up with a bunch of pods, all of them in the state of restarting, and then resources get thin, and if you have tinted nodes, the cluster just freezes. It's a really nasty situation, so I think I should share that one with you. Now about the future. Of course, we are going to find a solution to our logging problems. Hello? Oh, we're back. So we're going to go into distributed tracing, and we are going to move some of our legacy stateful apps into the cluster. Of course, they are going to be modified to conform with the cluster reality and Kubernetes needs, but we are going to deploy them anyway. In summary, I find that this project is quite successful one, even though we have had some problems along the way, and none of them caused us to drop out of the net, or didn't cause the service degradation so big that we would lose a considerable amount of money. I think that it is also a clear sign that cloud might not always be the best solution for your workload. Are there any questions?